Yeah, apparently my spiel asking for help to figure out how to like solve the problem of in of x because the teachers won't accept the obvious solution to the problem they're creating, which is write the quiz by hand in cursive so that everybody knows it's a L, lowercase l. They won't do that, of course. They gave it 0 seconds of thought and without hesitation came up with 3 different random excuses why they couldn't do that. Even though I've taught 20,000 students here, that was never a problem, not once. So now it's constant. Well, you can't type lowercase l, can you? Right? It looks like a capital I. But they are so bent on grading, giving grades for memorizing the names of things, but they can't tell if the students mean capital I-O-G or lowercase l-O-G, since they look the same when the students write it. So they don't know if the students are getting it right or not, but they're okay to ignore that. But you can't ignore iog or in of x. Iog. And the one solution that's obvious, because again, I taught 20,000 students and it was never a problem in the first place. It's a problem they're creating. They won't even consider the obvious solution. So maybe they'll consider the other one. Let's just rename log iog. That sounds way harder. They'd probably be into that.
I don't get it because it says log.
No, they see that as a capital I.
Well, log is because
well, yeah, you'd think, but you see, they're not thinking. They just look at this, and because that horrible font, because the tech industry is incompetent because they were taught by math ed people, right? They see a capital I, but then they're too lazy to write capital I, and then they put lowercase I, right? Normally you get in of x, right? This one had something weird about it. I forget what it was.
I like how they use L and then they switch to I.
Yeah, they did, didn't they? They did that here, but then over here, yeah, capital I, maybe, maybe not, all right? And where is the equal sign? I mean, I tell you over and over again, put equals between things that are equal, don't put it between things that aren't, right? So here we got 3 different versions. And this is the redo. This is after I spent 15 minutes asking people to help me to figure out why people are making this mistake. All it did was make people make the mistake more because they don't understand any of the words coming out of my mouth, even if it's simple English, right? Here it is, capital I-N. That one I never saw very often, but it clued me in that the lowercase I was really their uppercase I, but too lazy. That's how I figured that out, right? I don't know what, okay, log. This, it should be condensed. I keep asking the teachers to take the word should out and say it can be. Then they won't do it. It doesn't have to be condensed. The equations, the rules go both ways. Here you use them one way, here you use them the other direction, right? Why is this, where's this should coming in, right? I like this one. Oh, nice and cursive, right? Now, I don't write the whole word log cursively, right? Just the L, so it's disambiguated, right? That's all. But they took it like, I'm going to do the whole thing in cursive, right? Like math has to be done in cursive. No, it's okay. This one, they use capital L and lowercase I, which are both not correct. Yeah, but the thing is, if they do a regular old line for L, I don't know if they were actually meaning capital I. And since it's so important to grade the knowledge of the names of things in English, right? You'd think they'd want to know what the student actually meant, but no. This student actually came and argued with me that the PlayPosit videos, the lady wrote IN, lowercase IN, which she did not, right? Here, I like this one, beautiful work. I was just interested in why she would use the cursive L here, but not here. You follow? It's the same letter, the letter L for log, right? Natural log, log. So I asked her, she was so afraid that she did something wrong. And I'm like, no, you didn't do anything wrong at all. I'm just interested in why you would switch how you write a specific letter from one context to the other, right? This person, after I was like, write your whole name, right? One, they didn't write the whole name, and this is when I have a piece of paper with quiz written in bold on the top, and they couldn't write the word quiz, right? They made the highest grade in my class that semester. Because they came to office hours and asked me questions, and it turns out math is way, way, way easier to learn than English. My best student that semester, right? Here, what's up with this one? Uh-oh. Look, I have this rubric I have to use to grade you by, right? All the log stuff is absolutely perfect. So the rubric is perfect. And then look what they did. They just saw sevens and they just said, samesies. You can't do that, right? You can either multiply by 1, add 0, raised to the first power, or if you have a plus 0, choose not to. If you have a times 1, choose not to write it, right? That is something you definitely can't do. So how do I grade that? I have to click on boxes in a rubric, right? Because we're not allowed to actually think or use common sense when grading, because everybody has to be graded the same. Well, not every answer is going to fit into a finite rubric. You're going to make your rubric infinitely long, right? This is why I'm getting carpal tunnel. Meanwhile, I'm doing a 30-hour stupid teacher workshop online about rubrics for the whole class that's set up. It's a grade the teacher's class set up. It's like pure evil. Okay, and we got one more here. Why are they putting arrows again? Arrow, arrow, arrow. I don't know why. But that's enough of that. So, where is my... All right. You'll begin practicing to use the quadratic formula to solve quadratic equations. No. The quadratic formula is the solution to all quadratic equations, right? So you're not using it to solve, it's like that's the answer to all of them. Just replace A, B, and C with the numbers, and that's the solution, yeah? The rest of it, that's it. That's just replace the letters with numbers. But that's all they have you do is the arithmetic of simplifying the answer that's already been solved for you. But you just memorize the quadratic formula. You don't have to derive it, so you're not actually solving anything at all. So you're not doing any algebra. None. Zero. Zilch.
It's not doing math?
No. You're fake mathing, right? You're memorizing a whole bunch of busy stuff that when you do it, it makes it look like you've learned math. And it makes them look like they've taught. But none of that has actually happened. But they have this awful song, apparently, you can sing to help you memorize stuff. All right, yeah. So we could work some examples here. I used to have a guide over here. Let's see here. You have a number. Uh-oh. There we go. I have a number. Great. I got two numbers. Makes a point. 2 points makes a line. Great. Right? 2 lines. You can find out where they cross. Great. Well, the next complicated thing, again, instead of a number, you could think of it like that. Or you could have a number plus some other number, right? So really every number is this, if you want to think about it in the language of polynomials, right? All right. Here, every line or every linear expression, this is a linear expression, linear equation. This is a linear function. If you set it equal to 0, that's when you're finding out where it crosses the x-axis, where the y value is 0, right? And then the next step up, give me a number. So 0, 1, 2, right? I don't know. That's a polynomial algebraic expression of second degree instead of first degree. The number 3 is really a polynomial of degree 0. Okay? Follow? God dang it, man. He's bothering me. Now, great. So you could have this 3x squared equals 9. That's really 3x squared plus 0x minus 9. You can always put it in that form, right? And now you have your A, B, and C. Yeah?
Yeah, I see that.
Okay, so every quadratic, quad, 4 sides, square, rectangle, you can find an area. If this is a length, this is an area, right? So if x has units of length, you have a number x squared, a number times x, and then a number, right? So again, if you think of x as having length, this is a number of lengths, number of areas, I should say, right? So I got a whole bunch of square fields. How many of them do I have? That many, right? Okay. This would have to be a length times a length to get an area. This, you have to think of it as two numbers, both having length multiplied together to have units of area, right? That's why a long time ago this was like 7 separate equations. This is a quadratic expression, quadratic equation. Here is a quadratic function. And if you graph it, instead of getting a straight line, like you would if you only had that, you get a curve called a parabola that looks just like this. Okay? Now, if I put myself in the universe right at what we call the vertex, right, which is a turning point, it's where it turns around, right? And since there's only one, we call it the vertex, right? This is x squared. Every single version of this where you have a x squared is really 1x squared plus 0x plus 0, right? Yeah? That's your ABC. So you could use the quadratic formula to solve where it crosses the x-axis. Of course, you're going to get 0, okay? Yeah, so yeah, because if you set x squared equal to 0 and you solve, what do you get? 0. Actually, you get it twice, right? Yeah, because it's squared. There's always two solutions because of the fundamental theorem of algebra, right? So really, it's the answer is 0 and 0. So we would say the 0 of the function is 0, but it has multiplicity 2, which is going to be important here, this word multiplicity here soon, right? So great, you can do that, and if you are going to figure out where your function, I mean, you could keep going, you know. Let's say I had a higher degree one, and I'll call it g of x. Here is a cubic. Okay? You just keep going higher powers. This is a third degree polynomial, okay? Now, in general, this guy is a parabola. This guy looks like that. If I went to 4th degree, I'd have that. 5th degree, the more the powers, the more wiggles you get, right? Okay. Every parabola can be written this way because it has symmetry. Yeah? You can move it up or down. You could take x squared, move it up or down, left or right, stretch it vertically, but that looks like compressing it horizontally. Those are the same. So that's why you only have 3 parameters. 1, 2, 3 gives you every one of them. Okay? But
What causes it to rotate or flip?
oh, if you check it out. If I take this guy, well, let's use Desmos. Boom, ba-doom, boom, 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 boom. Well, y'all should do this. Make your own thing. F of x, right, equals a times x squared plus b times x, right, plus c. Well, all I have to do is give them an a, b, and c, and I have an actual function. It automatically uses 1. So that's 1x squared plus 1x plus c, right? This is way better to learn functions. Instead of doing the graph of one at a time, check it out. As I drag the slider, it's a different function. Every time a changes, that's a new function. So you're looking at an infinite number of functions right now in 3 seconds.
Oh, that's cool.
Yeah, so what are we doing? I'm treating the coefficients like they're variables. So this is a class of functions right here.
What did you do to get to that?
I just typed in the expression, and then, oh, it's tickle time for my daughter. Yeah, and then I made this so I could do this. This is what y'all should be doing. So look, A makes it taller, 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 right?
Yeah.
Okay, so what happens when it becomes negative, right? Well, if I smash it by making a smaller, right? Smashing, smashing. If it's 0, I've smashed it flat, right? If I keep smashing it,
Now it's just
it flips upside down, you see? So A being positive opens upwards. If it's at negative, it opens downwards, which it's easy to see that by boop, instead of memorizing positive upward, negative downward, right? In 3 seconds, suddenly you have this intuition where it's simple and blatantly clear and not something now you memorize. Follow? Yeah. So what does the B do? Well, check it out. If there was no x squared and you only had this, then it would be a straight line, right? B is the linear part. So what does the B do? If I make a B bigger, it seems to have to do with the shift, right? That's kind of weird though, huh?
What kind of shifts?
Here, let's put A back. Let's put A back to 1 here, right? So it's right. If B is 0, what does that mean? Look, the vertex is right on the x-axis. But remember the vertex formula, negative b over 2a tells you the x value or the axis of symmetry. So yeah, if it's 0, you're right here, and the right side's the same as the left side. It's an even function is what we call it. But that's kind of weird. It just kind of makes it go over here, and it kind of makes it go over there. Huh. Right? They don't ever even talk about that. What about the c value, the constant? Watch this. Come here, buddy. It just moves it up and down, right? Well, it's just a constant. You're just adding a number to your y value, right? Well, that moves it up and down. You follow? But look, the b also has a little bit to do with the up and down, doesn't it? Oops. Why would the b have something to do with up and down as well? Well, a line has, we say it has a slope, right? It goes up and down, right? So it would contribute some. Because all you're doing is adding this y value to this y value to this y value, right? Look at them separately. This guy is a graph of this function, right? Where'd this one go? Oh, wait. Oh, they're the same. Oh, I need to change these here to some numbers, right? Okay. Take that function, take this function, and take this function. Take the y values of those 3 functions and add them together, and you get the y value to that one, right? So check out, if I change b, now I'll check it. See that line, that straight line? That's the bx. See how it's contributing now?
So that's like the slope.
Yeah, you see?
We're changing the slope of the y.
Yeah, you see, now you can...
Broken up like this.
Now you can, yeah, that's what you want to see. That's what we should be showing you, because y'all could do this amplify basic stuff outside of class. But again, y'all should have learned all of that in pre-algebra. You know what I mean? But we're going to just waste all your time where you don't learn pre-algebra again instead. Okay, here's the other thing you're missing here. You can also write one of these like this. If that's f of x, we could do, I'll use lowercase a because it's the same. And I already used a, b, and c, right? Dang it. I'll use capital B, right? X. No, they do it like this. X minus h, okay? Plus k, right? Well, f just, well, no, I got to change it. Let's do it this way. I won't do it that way. Well, I can't. I'm going to do it. I'm going to do it. Watch this. Let's just make g of x just regular old x squared, okay? So I'll show you every parabola is really just x squared transformed, okay? So you take x squared, I can move it to the right or the left, up or down, and then stretch it, right? So will it let me do this? H, I want a slider here. Maybe it makes me to do this. Boop, there, boop. All right, so I got my x squared here. I'll hide these for a second, okay? All right, so, all right, hk, up or down, yeah? Yeah, and then my a value, that's it, yeah? So mathematically, why we don't do the multiply the input, well, look, here's a quick example why. 3x squared. This is x squared, but compressed horizontally by a factor of 3, right? Well, that's the same thing as 3 squared times x squared. It's the same thing as stretching it vertically by a factor of 9. You see that? That's why we don't need that fourth parameter, and you only need 3 of them, right? So that's vertex form, okay, which instead of saying g of x is x squared or whatever, I could just have done this. Oops. Okay, that's your vertex form. Yeah? Okay. And instead of h, I could have replaced h with negative b over 2a. Yeah? Because that's what it is, isn't it? From general form up here, they have you memorize that, right? Okay. And you could also do factored form. So check this out. I'm going to do, let's hide this guy. H of x equals stretch factor x minus z sub 1, and then x minus z sub 2, where those are the zeros. So if these are both 1, let me hide, is that? Why do I have 2 graphs? I only want 1. Oh, you need to go away. There you go. They're both 1, right here. You're getting the same answer twice. So what would that be if they're both 1? And whatever my a is, what is my a up here? 2.5. I'm going to move him down here. Come here, buddy. Okay. This guy's still the stretch factor. Look, yeah? Okay. What does that look like? If a is, I don't care, 7, 4, whatever, x minus 1, that's really this. Set it equal to 0, divide by 4, right? Square root, add 1, right? When you do that square root, you're getting plus or minus 0, so that doesn't do anything, right? So you're getting the same answer twice, okay? As multiplicity too. That's why they say if there's an exponent on your factor, that's its multiplicity. You're getting the same answer twice. That's what happens when it just touches, right? Now this way, look, I'm moving it to, what is it, 4? There, 4. You see that? So don't look at the rest of it. Just look at where it crosses the x-axis. You see that? The other one, I'm going to put this one at 2. I could put over here at negative 4.1, right? Now the reason why we don't use this as a form, we could, but this guy, the ax squared plus bx plus c, the a, b, and the c can be any real number you want, right? And you get any parabola you want. Here, if you want to get every parabola that you want, you can't restrict the zeros to being real numbers. You'd have to include complex numbers as well. What? Why is that? Well, check this dude out. I don't know where my a went, but look at this. Where does this guy cross the x-axis at? What would you have to plug into the function for, I forget, where's my a? 2.7 x squared, right? Here we could actually do this. Let's make it a nice whole number. 2x squared plus 2x and plus 2. That's real simple. 2x squared plus 2x plus 2. What do you plug in to make it 0? The only number is 2. You'd have to plug in a complex number, right? Because if you did the quadratic formula, right? 2x squared plus 2x plus 2. I want to find the answers. The quadratic formula says it's negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, great. What is that? Well, check it out. This dude is bigger than that, and you're subtracting, so this is a negative number, right? Dang it. Well, hell, as soon as I have x squared plus 1 equals 0, right? And you want to solve, right? Okay, So you have to extend your numbers to the number plane, the complex numbers here. That means what we should be looking at is plugging a plane into the function and getting a plane out. But to see all the inputs and all the outputs together, that's four-dimensional, hard to look at. So instead of just having one picture that's 2D, to get all four dimensions to see them, we do two graphs. One of them that's 3D and another one that's 3D. One of them's missing one dimension, the other's, right? But when you do that, you kind of get the whole picture here, and there are some really nice things you should look at. Let's see, complex graph of parabola, quadratic. Do that. Here's some cool ones. A complex graph. There you go. Check it out. You see what y'all see is that parabola? That's just a two-dimensional slice of a four-dimensional. Oh, man. Oh, come on, Internet. Where'd you go? Oh, can I drag? No. Dang it. Anyhow, it's like a saddle. You follow? Yeah. All right. But again, you're only seeing 3 out of the 4 dimensions. Okay? So imagine it's kind of like a bowl here, a round 3D bowl, right? Yeah? All right. So where's this parabola? Well, look, to the right and to the left is your real numbers that are going in, yeah? And along that line, the plane that goes straight up right there, all right, those are the numbers that are the real numbers that come out, yeah? So on the other side of this parabola and on this side of that parabola, that's going to be a part of the complex numbers you're plugging in, right? Because you're plugging in a plane and getting a plane. Right there you can see the line you plug in along with the other line that you get out together. So what are these axes here? Check this out if I can find it. There's a really cool picture that shows there are graphers that can graph this. Maybe this one. No, this one's ugly too, but you can see again, there's your parabola. Here they're kind of labeled, so I still can't see that very well. I had a nice picture on my other laptop here I wanted to show y'all. But, sometimes they do color. Well, there is a graphing website that lets you manipulate it to see it. Complex roots. Yeah, let's just do complex valued function grapher. This guy, complex function plotter. What? There's 3 dimensions here. Left, right, up, down, yeah? And color. Check it out. This is, when you only restrict your domain to real numbers, we like to call the input x. If there's only one variable. If there's more, you go x, y, z. But if you're only having one variable and you don't restrict to real numbers and you allow complex, we like to call the input z. So this is the function f of z equals z minus t, where t is anything. But let's do z squared because that's your parabola. This is x squared, but this is 3 out of the 4 dimensions that come out. Now watch this. You know x squared comes down and it touches the origin, right? So the zeros are at the origin. Look where this circles things happen. You see that? Right there at the origin, yeah? Watch this. Let's move our parabola, our x squared, up where it's not touching anymore, right? Consider this example. F of x is x squared plus 2. Okay, 1, 2. Boop. Oh, the zeros are imaginary numbers now, right? Here we could do plus 4, right? So that the zeros would be positive, negative 2i. Yeah? All right, watch this. Plus 4.
Oh, so the zeros are where?
Boom, positive, negative 2i. Samuel J. Lee. you see how the most useful stuff is so hard to find because the whole internet is just crowded with garbage, the same idiotic nonsense over and over and over and over again by the people who are they lack the confidence to think. You know what thinking and knowing is, right? What do? You think until you know. What does that mean? I know, that just means I'm confident that I've thought about it enough to where I've found all the data I can find, and I've looked at the data every which way I could, and so if I'm wrong, at least I did my best, right? And sometimes you're wrong, and when you are, that motivates you to find new ways to get more data next time and find better ways of looking at it, right? So that later in life, when you say, I know, that means something different than what you used to mean. It's the same thing, it just means you have more confidence in yourself and what you mean. When you give up thinking and you say, I know, it means you're confident in your skills of collecting the data and analyzing it, right? So as you grow older and older and older, the more you think, the better you get at being confident in yourself, because that word, I know, it just represents your percentage of confidence in your skill for collecting data and making sure you've exhausted every point of view that you have accessible to yourself. But you can never truly know, right? It's impossible to have all information. You're not omnipotent, right? But the better you get at it, the better you have that confidence level that's like, I might not know for sure, but I know with more confidence than anybody else on the planet. And you can get there real quick simply by thinking. If you always just immediately know, or you don't bother to think because you're looking for somebody else to know, and you just accept what they say, well, guess what? You're just looking to everybody. Well, could everybody be wrong about something? Well, look around. They're just making as much plastic as fast as they can, throw it into the ocean, right? They're just destroying everything as fast. Obviously, everybody is almost always wrong about almost always everything, right? So use your brain. This is cool. This is 3D out of 4. And just play with it. You're going to have to learn complex numbers in pre-cal. The coolest thing about, it moves. When you multiply your numbers, they rotate, right? Think about where I is. It's straight up, right? What's I times I? It's -1. Yeah? This guy. Here's your number plane, right? We call it C for complex. Here's 1, here's -1, here's I, right? Where is it? It's at 90 degrees straight up, yeah? When I take I and I multiply it by I, that's -1. That's right here. You took 90 degrees and added 90 degrees. When you multiply this number times itself, you end up over there. That's why a negative number times a negative number gives you a positive number. When you multiply your numbers, they're literally rotating. A positive has an angle of 0, so another positive with an angle of 0. You multiply them, you still get an angle of 0 plus 0. Yeah, so now multiplying is just rotating the plane. Boop. Right?
That makes more sense.
That's all it is. Take your number plane. If you multiply every single number in the complex plane by a negative number, the answer is in that plane rotated 180 degrees. Again, if you do it to every number, what are all the answers, right? It's just the plane's just been rotated.
That's crazy. Somebody found this out.
Well, it's just obvious because they take every single step to be understood at the level of a pre-K student, a 4-year-old. Every step. Any leap more than that is some wild-ass assumption, right? And that's not how we do things. So y'all aren't offered the time or opportunity to sit there and think about it so that it can make sense to you at a 4-year-old level, because all your entire youth is wasted memorizing this nonsense because people who don't understand anything at all, literally anything at all, they just know stuff, are the ones who are in charge of your entire life.
I got one more question.
Yeah.
Do you know where the SimSpace building is?
No,
Do you know what that is?
I've never heard of it.
You have it right there.
So yeah, play with that. Use your Desmos, save your account, make a folder, quadratics, and play. Tinker with it. Yeah, y'all are going to be masters of the universe. My 2 good students out of 60. Yeah, it's awesome. I love it.